Hello everyone, this is Salma Shabnam from Department of Mathematics, St. Joseph Engineering College, Mangaluru. Today we will learn about sampling distribution. First, we need to understand the definition of sampling distribution in general. Given a population, consider a set of samples of certain size drawn from the population. For each sample, suppose we compute a statistic, say mean, standard deviation, etc., then these statistics may vary from one sample to the other. We group these different statistics according to their frequencies and form a frequency distribution. The distribution thus formed is called the sampling distribution. If the statistic is mean, then the sampling distribution is frequency distribution is called the sampling distribution of means. These are the definitions we are using in this context. Population is the large group of individuals whose data is to be studied or analyzed. Sample is a small subset or a part of the population. Size, capital N, is a number of elements in the population which may be finite or infinite. N, small n, is the number of elements in the sample. Random sampling is a type of sampling process in which every member of the population has equal chances of being selected in the sample. Sampling with replacement is a type of sampling where each member of the population may be chosen more than once. Sampling without replacement is a type of sampling where every member of the population cannot be chosen more than once. The measures such as mean and standard deviations associated with the population are called parameter, whereas the measures associated with the sample are called statistics. The notations so used are capital N is the size of the finite population, small n is the size of the sample, mu is the population mean, sigma is the standard deviation of the population, mu x bar and sigma x bar are nothing but the mean and the standard deviations of the sampling distribution of means respectively. Standard error is nothing but the standard deviation of the sampling distribution. The formula for sampling distribution of means in regard to the random sampling with replacement is the mean of the population is same as the mean of the sample, that is mu x bar is same as mu. Standard deviation is sigma x bar is same as sigma by root n, where n is the sample size. Random sampling without replacement, here the mean of the sample is same as the population mean and sigma x bar is some constant times sigma by root n, where the constant is nothing but root of capital N by root of n minus n. This constant becomes 1 when capital N is very large. It can be proved that for samples of large size or for samples with replacement, the sampling distribution of means is approximately a normal distribution for which x bar is the random variable. If the population itself is normally distributed, then the sampling distribution of means is a normal distribution even for samples of small size. Since we are dealing with normal distribution, the standard normal variate associated with the random variable x bar is given by z is equal to x bar by mu x bar by sigma x bar. To understand these definitions, we have an example here. A population consists of 5 numbers 2, 3, 6, 8, 11. Consider all the possible samples of size 2 which can be drawn with replacement from this population. Find the mean and the standard deviation of the population, also the mean and the standard deviation of the sampling distribution of means, and considering the sample without replacement, find the mean and the standard deviation of the sampling distribution of means. The sample size here is 5 because we have 5 elements in this population 2, 3, 6, 8, 11. The population mean is the average of these 5 elements. And the variance sigma square is given by sigma is nothing but the sum of each member, the sum of the squares of each member minus the mean of the populations divided by the number of elements in the population. So this comes up to be 10.8. The standard deviation is root of the variance is root of 10.8 gives us 3.2863. Now, to find the mean and the standard deviation of the sampling distribution of means with replacement, the possible samples of size 2 are formed as follows. We have 2, 2, 2, 3, 2, 6, 2, 8, 2, 11. 3 is associated with all the members of the population. Then 6 gets associated with all the members of the population. Similarly, 8 and 11. So we have 25 here. The means of each of these samples are calculated. That is 2 plus 2 divided by 2. The first case, we get it as 2. 2 plus 3 gives 5. Divide by 2 gives us 2.5, so on. So since many numbers of the means have been repeated here, we form the frequency distribution. So 2 appears only once, so frequency is 1. 2.5 appears 2 times, so the frequency is 2. We observe that 7 appears 4 in the table, so the frequency is taken as 4. So this frequency distribution is called the sampling distribution of means. So in this case, the sample mean is calculated by the statistical formula sigma fi into xi by sigma fi, which gives us 6. Sigma x square is the sum of the frequency, the product of the frequency fi with the square of xi minus the mean mu x bar, the whole square, divided by sigma fi. So this gives us 5.4. So now, considering the sampling without replacement, the possible samples, we remember that each number cannot be repeated again, or a set of numbers cannot be repeated again. So if we go back to this, we see that 2 and 2 cannot be taken in that set without replacement. 2, 3, 2 gets associated with all the other members other than 2. So 2, 3, 2, 6, 2, 8, 2, 11. So this gets included. So we see that again 3, 2 cannot be taken because 2, 3 is already there. 3, 3 cannot be in the sample. We take it as 3 gets associated with 6, 8 and 11. Next 6, 2, 6, 3, 6, 6 cannot be taken, but 6, 8 and 6, 11 gets included in the sample without replacement. Okay. 8, 2, 8, 3, 8, 6, 8, 8 cannot be repeated, cannot be taken because already it's previously taken. So 8, 11 gets included in the sample. So we have 2, 3, 2, 6, 2, 8, 2, 11, 3, 6, 3, 8, 3, 11, 6, 8, 3, 6, 11, 8, 11. So sample size is 2. So mean of each of these samples are calculated. Here we do not form the frequency distribution because most of the means are repeated only once. Appears only once. So mean is just taken as a raw data. We take the sum of the means divided by 10 gives us 6. Sigma x bar calculated by each member, the square of each member minus the mean. The sum of all these numbers divided by 10 gives us 4.05. So sigma x bar comes up to be the root of 4.05 standard deviation. So the next example we have here is the weight of 1500 ball bearings are normally distributed with a mean of 635 grams and a standard deviation of 1.36. If 300 samples of size 36 are drawn from this population, find the mean and the standard deviation of the sampling distribution of means if the sampling is done without replacement and with replacement. In the first case, without replacement, we first carry all the data what is given to us. The population size is 1500, population mean is 635, population standard deviation is 1.36, the sample size n, small n, is 36. So without replacement, we see that the sample mean needs to be found out, which is same as the population mean is 635, and sigma x bar is calculated by this given formula, gives us 0.224. So with replacement also we know that the sample mean is same as the population mean, therefore it's 635, and sigma x bar is calculated as sigma by root n, gives us 0.2267. Now in the third example, we consider the same data as given before, as in 2. We need to find out how many random samples have their mean between 634.76 grams and 635.24 grams and greater than 635.24 grams. In this case, we need to consider that sampling distribution of means is normally distributed. So therefore, the standard normal variate associated with the sample mean x bar z is given by z is equal x bar minus mu x bar by sigma x bar. Substituting this data, we have z as x bar minus 635 by 0.2267 because the data is with replacement. So we need to calculate how many samples among 300 lie in between the means 634.76 and 635.24 grams. So for this, we need to calculate x bar lies between these two means. So substituting x bar in z, we get z lies between minus 1.0587 and plus 1.6587. So using the normal distribution table, we get the probability that the sample lies between these two means is 0.7062. So since the probability that one sample lies between these two data, then for the 300 samples, we multiply this probability with 300. We get the number of samples which lie between 634.76 and 635.24 grams. It happens to be 212. Now the number of samples which have means greater than 635.24 grams, we need to find out the probability first. So we find out the probability x bar greater than 635.24. The corresponding standard normal variate happens to be z greater than 1.0587. Using the normal distribution table, we get the probability of that a sample has mean greater than 635.24 is 0.1469. Now the probability that the number of samples having mean greater than 635.24 grams is, multiply the probability with 300, you get it as 44. Now another example on sampling distribution of means. Certain tubes manufactured by a company has mean life of 800 hours and standard deviation of 60 hours. Find the standard probability that a random sample of 16 tubes from the group will have a mean lifetime between 790 and 810 hours, less than 785 hours, and more than 820 hours. We observe that the population mean is 800, the standard deviation of the population is 60, and the sample size is 16. So similarly, the sample mean happens to be 800. Sigma x bar is calculated as 15 because we have a sample without replacement. Okay. The standard normal variate associated with the sample mean is given by z bar minus mu x bar is 800 and sigma x bar is 15. Now we need to calculate that the probability that first we need to calculate the probability that a random sample will have mean lifetime between 790 and 810 hours. So we substitute x bar in z and we get z lies between minus 0.667 and plus 0.6667. So by the normal distribution table, we get the probability that a random sample will have mean lifetime between 790 and 810 as 0.4844. Similarly, the probability that a random sample will have mean lifetime less than 785 hours. So substituting x bar as 785 In Z, we get Z is less than -1. Using the normal distribution table, we get the probability as 0.1587. Similarly, the next one, we have the random sample will have more lifetime more than 820 hours. So similarly, substitute in Z, we get it as Z is greater than 1.83333. From the normal distribution table, we get the probability is 0.0968. That's all for sampling distribution of means. Thank you. Happy learning.